Hi to everyone. MEM School of Engineering, Department of BC, online classes, subject linear integrated circuits, unit number 3, chapter number 5. So last previous classes we discussed with the analog multiplier, PLL and voltage control oscillators. Okay. So in this chapter we are going to discuss about monolithic PLL IC 565. That means what is the internal circuit diagram of 565, then operation of IC, PLL IC, then different parameters and characteristics of the IC 56. Okay, so let's see. So monolithic PLL IC 565 are introduced by the Signets as the series by National Semiconductor with the 560 series. These ICs are differ mainly in the operating frequency range, power supply requirements, and frequency and bandwidth adjustment ranges. The PLLIC 565 is usable over the frequency range 0.1 Hz to 500 kHz. It has highly stable center frequency and is able to achieve a very linear FM reduction. The output of VCO is capable of producing PTL compatible square wave. The dual supply is in the range of plus or minus 6 volt to plus or minus 12 volt. The IC can also be operated from single supply in the range of plus 12 volt to 24 volt. So PLL black diagram, the input signal VA phase detector, then output next to the forward path to the low pass filter, then next to the voltage control oscillator. The output of the signal will connect to the phase detector. So this is the PLL block diagram, basic black diagram. This is the internal schematic of the PLL, that is a 565. It is as 14 pin package. So pin number 1 will be minus P, that is power supply. Then input 2 and 3. Then VCO output 4. So input to phase deduct from VCO. Reference output, demodulation output. Then 9 will be external capacitor for VCO. R will be internal resistor for, external R for VCO. Okay, why in our mind it will be a question rises. So like why we are connecting the external C and R? Okay, by varying the frequency of VCO, we need to define the R and C value in the different conditions. If we build in the IC means we can't change the value. So we are using the capacitor and resistor in the outside. Okay, already we know that F is equal to 1 divided by 2 pi RC. So the resistance and capacitor connected in the outside of the VCO. This is the another model, another package of IC 565. So each pin is explained in this slide. It is a 14 pin IC operated from dual power supply plus and minus volt. Then pin number 2 and 3 are signal input for phase detector. Pin number 4 VCO is available, output is available. Pin number 4 and 5 are shorted externally so that VCO output is supplied for phase detection. In some applications, PLL loop is broken and some circuit is to be connected between pin number 4 and pin number 5. Pin number 6, reference DC voltage is available. Pin number 7, demodulated output. If input signal between pin number 2 and pin number 3 is FM signal, so then the pin number 7, we get FM demodulation output. Pin number 8 and 9, external R1 and C1 for VCO, that is determines pre-running frequency of VCO. The internal resistance R2 and the external capacitor C2 forms a low pass filter. The value of internal resistance R2 is 3.6 kilo. So this is the internal schematic of the 565, that is phase detector, amplifier, and VCO. They are using the R1 and C1 as the external capacitor and resistor for this circuit. Okay, as well as for low pass filter also they connect the external capacitor for selecting the frequency of the low pass filter. Okay, so this is the diagram. The 565 IC is available as a 14-bit DIP package. The output frequency of the VCO is F0 is equal to 1.2 divided by 4 RT and CT, where RT and CT are the external resistor and capacitor connected to the pin number 8 and 9. The value between 2K and 20K is recommended for RT. The VCO pre-running frequency adjusted with RT and CT so that it is the center of the input frequency range. So then features of IC 565. Okay, where it is used IC 565. That is extreme stability of center frequency type 200 ppm, wide range of operating voltage plus or minus 6 volt to plus or minus 12 volt, very high linearity of demodulated output typically 0.2%. So center frequency of VCO is programmable by means of resistor, capacitor or voltage. The TTL compatible square wave output, highly linear triangular wave output available at pin number 9. Loop can be broken between pin number 4 and pin number 5, and the external circuit can be added. So frequency adjustable over the range of 1:10 with a single capacitor. So this is a design equation for the different parameters. First one is central frequency. F0 is equal to 0.3 divided by R1C1. Then is log range of the VCO, that is FL is equal to 8 F4 divided by V, where V is equal to plus V and minus V. 3. Capture range, FC is equal to plus or minus 1 divided by 2 pi root of 2 pi CL and R2 and C. So this is the login range, the same equation that is different. The cutoff frequency F is equal to FL divided by 2 pi, 3.6 10 to the power 3, C2 into 1 whole power 1 by 2. So these are the expected waveforms in the output side. That is free running frequency, lower locking frequency, lower capture frequency, higher capture frequency, and higher locking frequency. Okay, these are the applications and the internal block diagram explanation of the PLL IC monolithic. So the pin number 7 and 6 will produce the demodulated output, and 6 define the reference output. So the phase comparator output will get in the 5, the VCO output will get in the 4. The power supply will be a plus 12 volt or plus or minus 24 volt. Okay, there's other reference voltage. Okay, we have to differentiate the VCC and plus V and minus V. These are the control voltage for the PLL circuit 565. Okay, thank you. So next class we will see the last chapter of unit number 3, that is application of PLL, that is AM detection, FM detection, like that we will discuss in the next class. Thank you.